Today's lesson is on reflections. We'll learn how to perform reflections, glide reflections, which are translations with reflections, and identify lines of symmetry, as well as solve real-life problems involving reflections. A reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of reflection. A reflection in a line M maps every point P in the plane to a point P prime, so for each point one of the following properties is true. If P is not on M, then M is the perpendicular bisector of P prime, or if P is on M, then P is equal to P prime. The coordinate rules for reflections are x-axis. You're going to take the opposite of the second value, which they refer to as b. In our case, it'll be thinking of x comma y. For a reflection in the y-axis, you'll take the opposite of the first coordinate, which they call opposite of a. In our case, it'll be the x value. For reflection in the line y equals x, we're going to switch the coordinate points. Reflection in the line y equals negative x, we're going to switch the coordinate points and take the opposite sign of both of those points. A reflection is what is called a rigid motion. It does not change the size or the shape of the figure. In our first example, we'll look at some problems where we're reflecting an image over a line that's given to us in the question. We are asked to graph a triangle with vertices at 1, 3, 5, 2, and 2, 1, and reflect it into the line x equals negative 1 and into the line y equals 3. So the first thing we need to look at is where are those lines. X equals any number is a vertical line. On this page, I'll look at the lines, and then I'll show you the actual reflected image on the next slide. X equals negative 1 then would be a vertical line drawn at 1. Y equals 3. Y equals is a horizontal line. Y equals 3 then would be a horizontal line drawn at 3. If we would take and reflect the image, in the first one, here's our line again of reflection, x equals negative 1. Here's the original image, and then for the reflected image, we're going to count over the same number of units to the left as we were from the line to the right. So A prime will be 2 units to the right, A prime, the reflected image, will be 2 units to the left. C is 3 units to the right of the line, C prime will be 3 units to the left of the line, and then B, again we count how many units to the right, we go the same number of units to the left. So this is the image right here. Y equals 3, it's the same triangle that's graphed using the coordinate points. We graph the image. We reflect it over the line y equals 3. Again, the pre-image is ABC. The image is A prime, B prime, C prime. Graph segment AB with endpoints A at 3, negative 1, and B at 3, 2, and its image after a reflection in the line y equals x. Y equals x is a main diagonal line that will go through the graph. We'll see that on the next slide with the same idea of the segment. So once again, here's our line, y equals x. Here's our segment AB. Our segment A prime, B prime, we look at the coordinates of point A is at 3, -1. The coordinates of B are at 3, 2. Y equals X says that we're going to switch the coordinate points around, so that would make A prime -1, 3, and B prime at 2, 3. Graph segment AB with endpoints given and its image after reflection in the line y equals -x. Y equals -x is a diagonal line that goes through the graph the other direction, so downhill. Looking at the actual image, y equals -x, here's the line of reflection. A is at coordinates of 3, -1. B has coordinates of 3, 2. Our image point is going to be at 1, -3, and -2, -3. So we take the point and switch the x and y, and then take the opposite of both of those numbers. So if they were positive, they become negative, negative becomes positive. Graph a triangle ABC and its image after a glide reflection. A glide reflection is translate and then reflect. So the translation of the image is going to be 0 units up or down, and 0 units left or right, and 6 units down, and then reflected in the y-axis. So here's what this will look like. The original image is ABC. That's this one here in this quadrant. First it asked us to move it down 6, so this is moved down 6. And then we're asked to take that image and reflect it in the y-axis. So that will change the x-coordinate to be the opposite coordinate. You can see by the points. How many lines of symmetry does the triangle have? This triangle would have 3 lines of symmetry. Lines of symmetry indicate where it's symmetric with respect to the axes. And our last example, we're going to buy books. Your friend is going to buy CDs. Where should you park to minimize the distance you will walk? So we're going to use the idea of reflected images. So the first thing we look at is drawing a line that goes the same distance from B. We'll call that point B prime. So we have the same distance from B to the line and B prime to the line. Connect B prime with A. And where the line and A intersect, that will be our point. So we're going to park in that stall. And that's it for our lesson today.